Hello. In this video, we will discuss the SCR turn-off mechanism. So, SCR, it is also called silicon controlled rectifier. It is a special kind of diode. In diode, you have only two terminals, P anode and cathode, or PN junction, anode and cathode. So, in order to forward bias, what you have to apply is you have to connect P terminal or P type semiconductor to a higher voltage and N type to a lower voltage. By simply applying a forward bias, you can make diode to conduct. Similarly, if you want to turn off the diode, you have to apply reverse voltage. That means anode should be connected to a lower voltage, and cathode should be connected to higher voltage. So you can turn on and turn off turn on and turn off diode in a very easy. But SCR, it is a little complicated when compared to diode. It has three terminals and it can be shown like this: PN, PN. So there are four layers and three junctions, J1, J2, J3. This is already you are familiar. So this terminal is anode and this is cathode and gate. So what you have to do is you have to apply a positive voltage to anode, negative voltage to cathode. Then what happens, J1 and J3 is forward biased, but J2 will be reverse biased. So it will not conduct simply applying a positive voltage to anode and a negative voltage to cathode, unless you should not give a voltage greater than VBO, breakover voltage. Above breakover voltage if you give, it will conduct. So we will not consider that extreme case. So usually if you give positive anode and negative to cathode, only J1 and J3 will be forward biased, it will not conduct. But if you apply a gate voltage, then it helps to pass the current from junction 1 to junction 2 and junction 2 to junction 3 and reach the negative terminal of the battery. So that is how you turn on the SCR. Now in this, what we are going to study is a turn off, how to turn off the SCR. Okay, so turn off SCR means, you already know SCR, we have three regions of operation. One is reverse blocking region. In this, anode is connected to a negative voltage, cathode is connected to positive voltage. Another one is forward blocking region. This means anode is connected to positive, cathode is connected to negative, but gate you are not applying any signal, or gate pulse or gate voltage you are not applying. This is called forward blocking region because it is not conducting, it is in off state. Then another one is forward conduction region. Here you apply a forward bias voltage between anode cathode, and also you will apply a gate voltage. So then it will be conducting. It is called forward conduction region. Now objective of turning off a SCR is, you have to, here it is written, transition of SCR from forward conduction to forward blocking state. So it is conducting from this state to this state, you have to change. So that is called turning off. So what are the things you have to make so that a SCR can be brought from the forward conduction to forward blocking state? The first one is, you have to reduce the IA, means anode current. Anode current has to go below holding current. We know the definition of holding current. So anode current, when it goes below holding current, then it will go to the, this is the one of the steps to bring it back to the forward blocking state. Second one, sweeping out of charges from outer PN junction. Remember, J1 and J3 initially itself they were forward biased and they were waiting for a supply for the gate voltage. Once you apply that, then SCR will be turned on. Now this J1 and J3 are the forward biased, and you will have majority charge carriers passing through these junctions. So what you have to do is, you want to turn off means you have to remove this excess charge carriers from the outer layers. Outer PN junctions means one is J1 junction, another one is J3 junction. So you have to sweep out the charges from these outer layers. And third one, recombination of holes and electrons in the interior region. Interior region means J2. So before applying gate voltage, J2 was reverse biased. but when you apply the gate voltage, it helps to pass through this J2 junction, and current will be passing through this anode, between anode and cathode. Now you have to remove the charge carrier, holes and zeros within the J2 also. If you can do that, then you can tell the SCR is in forward blocking state. Okay, so thing is, you have to first anode current should go to below IH. Second one, outer junction layer, that is J1, J3, in that you have to remove the charge carriers. And third one, inner region, that is this J2 junction, there also you have to remove. So these three are there. So we'll see how we can do that one. So here the graph is given. This is the region when SCR is on. See, if SCR is on, the voltage across SCR, this is nothing but the voltage across SCR. This I can call VAK. So voltage across SCR will be 0 if it is conducting. If it is conducting. When it stops conducting, then you will see the voltage. Okay. Let us assume now SCR is conducting and it is carrying a load current of this. This is the anode current, it is conducting. Now what you have to do is, first you have to bring back the IA below IH. So what we will do, we will reduce some action, we will see how it is. We will totally reduce the anode current below IH. You can see this, there is a fall of this one. Okay. So when it is falling, it will be still conducting. The thing is, it should reach below IH1. Another thing we have to do, sweeping out extra charge from outer PN junction, then recombination of holes and electron in inner junction. When all three happens, then it is completely turned off. So what is happening here? Here anode current is reducing, but it is still in SCR is still on condition. What happens at T1? The anode current reaches 0. So that means it has already reached below holding current, but still SCR is still on, but carriers are still under favorable condition. It will start flowing in the reverse direction with the same flow. So it is falling here. With the same flow, it will fall up to here, up to T2, because though the anode current has brought back below IH, still carrier charges are available in J1 and J3 outer junction. Because of that, it will be still conducting with the same slope. So in the reverse direction also you will see the current. So this reverse current helps to sweep excess holes and electron. So that means whenever this reverse current is flowing, this also helps to sweep out all those extra carrier charges which are present in J1 and J3. So at T2, you can see at T2, when 60% of carriers have been removed, reverse IA decreases. So when it reaches T2, at this point, you can see now it will not go below this. So IA 0 point is this one, this is the 0th level. Now current will change from minus to 0. So current start decreasing because the 60% of carrier charges are removed. So that's why it is written here. So during this, when it happens, you can observe the anode cathode current. So you can see a negative voltage is developed. You can see here negative voltage. This one, this is a negative voltage. Why? Because a reverse current is flowing. Because of that, negative voltage is developed across SCR. Okay. During this, a reverse voltage is developed across SCR. Now let us see at T3. So at T3, what happens? Your reverse current also becomes 0. Your anode current becomes 0. So when reverse current is almost 0, excess carrier charges have been completely removed. So now what happened at T3, whatever extra charge carriers they are present in J1 junction and J3 junction, that is removed now. Now what happened? Now what is pending? We will see. Have been removed, completely removed, and up to here T3 we will call TGR. It is called reverse recovery time. From T1 to T3, this duration of time, it is called reverse recovery time. What happens in this? In this, the excess carrier charges present in J1 and J3 junctions are removed. That is what happens. Okay. Now, but still currents are still trapped in J2. You can just observe here. Now we have removed excess charge carrier from J1 and J3. But what about J2? Here still carrier charges are present, but they can't escape because J1 and J3 are now reverse biased. You do not have any, they are not forward biased, and you do not have any carrier charges. So the inner junction is J2, where the currents or where the excess holes and electrons are trapped. They can't go out because J1 and J3 is not allowing. So current is trapped in J2. So now they must decay through recombination. How I can remove that inner junction current? Only possibility is recombination. When we have the excess holes and zero, when they recombine, so that means you are removing that excess electrons. Okay, so this is possible. Only a reverse voltage is maintained across SCR for some finite time. So it is not like that you just reduce the anode current. You have to hold a reverse voltage. You can see here, this reverse voltage is still maintained here. You can see you have to maintain that reverse voltage so that the recombination takes place within the inner junction J2. So that time, you can see here, that time this is possible. Only reverse voltage is maintained across SCR for some finite time. That is called TGR. So at T for SCR is completely turned off. So you can see as this at equal to T4, now all the currents which are trapped in J2 are removed by recombination. So this T3 to T4, the duration, it is called gate recovery time. So the totally turn off will have two interval. One interval is T1 to T3. T1 to T3, what happens? Anode current comes below holding and the excess carrier charges in J1 and J3 are removed. Next time duration T3 to T4, here what happens? The inner junction J2, wherever whatever current is trapped in the J2, that will decay through recombination. Finally at T equal to T4, we can declare that SCR is turned off. So now SCR is completely turned off. See the comparison between diode and SCR. In the diode it was very simple. You apply reverse bias voltage, that's it. The diode will be turned off. But in SCR you have to do three jobs. One is bring the IA below IH. Second one, remove the excess charge carriers from J1, J3. Last one, the trapped current in J2 has to be removed through recombination. These three things should happen, and it will have two time period. One is called reverse recovery time from T1 to T3. Another one is called gate recovery time, that is T3 to T4. So this is what you have to write, the current waveform and voltage across the SCR waveform. Okay, thank you.